All right, we have tangent, average rate of change, mins and maxes. Start out with what would be considered no calculator. Consider the function f of x equals 1 over x squared minus kx. That's a constant, where k is a non-zero constant. The derivative of f is given by, and they even give you the derivative, so there's k's again. So let k equal 3. So if we put 3 in for these k's, we get, for this up here. 1 over x squared minus 3x. Write an equation for the line tangent to the graph of f at the point whose x-coordinate is 4. So we need a point, and I found the point here, and we need the slope. So we have the k's. The k is 3, remember, and the x is 4 now, so 16 minus 12, right? Right here, 16 minus 12. So the point is 4 1/4. If we put in 4 for x, we get 3 minus 8 up there, and 16 minus 12 again. So that is 4 squared, that's 16, that's negative 5. So if y minus 1/4 equals negative 5/16 times x minus 4. Let k equal 4 so that the function is 1 over x squared minus 4x. Determine whether f has a relative minimum, a relative maximum, or neither at x equals 2 and justify your answer. So I found the derivative just by plugging in the k. K is 4. So plug in 2, you get 4 minus 4 over 4 minus 8, and that's going to be 0. So now we do have a min or a max there. Possibly. There is potential now. So if we plug in 1, we get 2/9, which is positive. Plug in 3, which is negative 2/9, which is negative. This must be a local max at x equals 2 because f prime changes from positive to negative. Letter C, find the value of k for which f has a critical point. We know, we're leaving the k blank. That's what we're trying to find. And plugging negative 5 in for x. And now we want this to be 0. So in order to make this 0, we just need to make the top 0. So 0 is k plus 10 minus 10. We get negative 10. Letter D, let x equal 6 so that f of x is equal to, and we're plugging 6 in for k. Find the partial fraction decomposition for the function f. So we factor the denominator, that's a over x and b over x minus 6. And then we get common denominator. So we multiply this by x minus 6. We multiply this by x. Now we don't need the denominators. We're going to let x equal 6. That makes that 0. So 1 equals 6b. B is 1/6. Let x equals 0. So negative 6a is 1, and so a is negative 1/6. Well, I like to have the negative last. So the negative 1 over 6x, put that second. So we can factor out a 1/6, and then the antiderivative of 1 over x minus 6 is natural log absolute value of x minus 6. Integral of 1 over x is natural log of absolute value of x. Well, we can factor out a 1/6. When we subtract natural logs, we can write that as a division, and then, of course, plus c. I'll show you the rubric here if you want to take a look at the point breakdown and what you get for each problem. There we go. Calculator required. Grass clippings are placed in a bin where they decompose for 0 to 30. The amount of grass clippings remaining in the bin is modeled by A of t is 6 point, and you can see that. Where A of t is measured in pounds as t is measured in days. Find the average rate of change of A of t over the interval 0 to 30 indicate units of measurement. So we have A of 30 minus A of 0 over 30 minus 0. So there's average rate of change. It's old school slope. So negative 0.197 indicate units of measurement. Modeled by where t is pounds per day. So pounds, what would that be? Yeah, pounds per day. That's what I thought. So pounds per day. B, find the average value of A prime of 15 using correct units. Interpret the meaning of the value in the context of the problem. So A prime, find the value. A prime of 15. I just plugged this into the calculator. You can use math number 8. That gives you the value of a derivative at a certain time of 15 here. And then rather than rewriting, I just thought I'd copy it over. The amount of grass clippings in the bin is decreasing at a rate of 0.164 or 0.163 pounds per day at time t equals 15. Remember that it's important to say at time t equals 15 because that rate is only good for exactly at 15. Letter C, find the time for which the amount of grass clippings in the bin is equal to the average amount of grass clippings in the bin over the time interval 0 to 30. So in other words, we're going to take the average value of A of t. So 1 over 30 minus 0. Integral from 0 to 30, and that's going to be 12.415. Letter D, for t greater than 30, L of t, the linear approximation. Now, linear approximation is really just finding the tangent line. That's all it is. To A at t equals 30 is a better model for the amount of grass clippings remaining in the bin. Use L of t to predict the time at which there will be 0.5 pound of grass clippings remaining in the bin. Show the work that leads to your answer. So if we're going to find the tangent line, we need a point. So we have this as the point. Our slope, here's the slope. Here is the equation. So if we're going to put 0.5 in for x, we're going to subtract 30, multiply by that number, add that number, you get 35.054. Here is the rubric. I'll show that very quickly. You can see the point breakdown for each. Here's a third one. I don't know if we'll get to a third one in class, but in case we don't, here it is. The figure above or off to the right shows the graph of f prime, the derivative of a twice differentiable function f on the closed intervals 0 to 8. The graph of f prime has horizontal tangent lines at 1, 3, and 5. The areas of the regions between the graph of f prime and the x-axis are labeled in the figure. The function f is defined for all real numbers and satisfies f of 8 is equal to 4. So here's your initial value. So this has an area of 2, there's an area of 6, area of 3, and an area of 7 under the curve there. Find all values of x on the open intervals 0 to 8, not including 0, not including 8, for which the function f has a local minimum. Justify your answer. So a minimum, we're going from local minimum. What did I do? I said, oh, I got a local maximum. Let's change that to, let's see, let me make sure. Local minimum. Derivative goes from negative to positive. Local min at x equals 2, 3, 4, 5, 6. F prime changes from negative to positive. Let's make sure that's right. Here's the rubric. Yeah, x equals 6 is the only critical point. Got it. I had originally put a maximum in there. Shame, shame. B, determine the absolute value of f on the closed interval 0 to 8 and justify your answer. Determine the absolute minimum. So here's f of 0. That's an endpoint. Now they say that f of 8 is 4. So over here, we're starting with the value of 4. So if we go 4 minus, we want to go 4 and then subtract 0 to 8. We're going backwards. So we have 4, we're going to minus 7, we're going to add 3, we're going to minus 6, we're going to minus 2. And you get a value of negative 8. Here's the local minimum. That could be the overall minimum. So we're going to go 4 minus from 6 to 8. So we're going to subtract 6 to 8. If we're going forward, we would add. So 4 minus 7, that's negative 3. So negative 8 so far is the smallest value. And then the other endpoint, f of 8, they just tell us it's 4. So the minimum value is negative 8. It's happening at 0, but it says determine the absolute minimum. It doesn't ask where. You could put it, I'm sure you'd be fine, but it doesn't ask. See, on what open intervals contained in 0 to 8 is the graph of both concave down. So where is the second derivative negative, or where is f prime decreasing? Decreasing, because we really don't have information about the second derivative. We do very indirectly, But if we're given f prime, we got to talk about f prime. So where is f both concave down and increasing? So where is f prime greater than 0? Explain your reasoning. So I say f prime is greater than 0 and f prime is decreasing on 0 to 1. So f prime is decreasing and positive values on 0 to 1. And then the other place is 3 to 4. Now you can't go 3 to 6 because the derivative ends up being negative from, or 4 to 5. 1, 2, 3, 4. Yeah, 4 to 5. So 3 to 4. D. The function g is defined by g of x is f of x to the third. If f of 3 is negative 5 halves, find the slope of the line tangent to the graph of g at x equals 3. So this is the chain rule. They want to see if you know the chain rule. So we're going to multiply by 3, reduce the power by 1, but leave the inside alone. So 3f of x squared. And then multiply by the derivative of the inside, which is f prime of x. Now we just have to plug 3 in. So this is already 3. F of 3. Oh, they tell us that. Negative 5 halves. We're going to square that and then multiply by f prime of 3. Well, we know what f prime of 3 is. It's 4. Right here. F prime of 3 is 4. So do a little math. 3, that's 25 fourths times 4. You know, I suppose we could have just canceled that out and gotten 75.